Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay Raj, back with another Algebra 1 video for you all. And of course, today's topic, as you can see by the title, is all about absolute value. We're going to be going into the nth level of digressing this entire topic on absolute value, discovering exactly what absolute value is and how you can solve it equationally through expressions and expressions within equations when solving for your variables. So we'll get in through and develop as we go throughout this lesson. It's going to be a fairly short lesson, so please make sure to tune in. It is a very important lesson, however, so that's why we've actually broken this apart into its own section within our absolute value inequalities unit. This unit is building up by looking at our compound inequalities and our basic inequalities in our previous video in this chapter, and then afterwards we're building up to our absolute value properties, and then in our very last lesson within this chapter, we're going to reach our ultimate goal of identifying absolute value inequalities, a mesh of those two lessons. So this is our next stepping stone and our last stepping stone towards absolute value inequalities. But before we jump into today's lesson, please make sure to do 4 things. Please make sure to smash that subscribe button, turn on post notifications, hit that like button, and also comment down below. Also, as a 5th thing, just to remind you all, utilize that share button on our YouTube channel just to make it easier if you want to share with any others, or maybe even share it to yourself and save it and store it with you so that you can revisit that given video. So now that all of that's out of the way, we can actually jump into the video. Let's take a brief overview of what absolute value is. Now, this is something you've probably learned in pre-algebra, but let's try and overview it, review it, and then start to apply it to more complicated concepts to build us up and prepare us for that final lesson within this chapter. So, what exactly would I substitute absolute value for in terms of a simple meaning? That's distance. It's all about distance. So distance, that's all absolute value represents. And distance is all relative towards a specific point, and I'll tell you exactly what that is. So absolute value, by definition, is the distance on a number line between a number and 0. So any number could be an integer, it could be a decimal, repeating, non-terminating, anything on the number line that's a real number. It's going to be calculated between its distance from 0. So wherever it is on the point, you'll calculate the distance from 0, and that positive value is going to be your distance. And like I said before, algebraically as well, absolute value will always alter any given number or expression to its positive value. So once you put those bars around a certain expression or a given value, it automatically changes the answer to the positive form. Graphically, the absolute value of a given expression or value will always have 2 valid values for the variable x. So whenever we're utilizing the variable x and we're trying to find the absolute value of x, or an expression with x, like x minus 1, x plus 2, all those kinds of expressions, there's always going to be 2 valid values that you can substitute for x to still get the same answer in your equation or in your equation. And I will go over that in our last slide, in our last couple of slides, going over variables and expressions with x. So if I were to utilize a basic algebraic question here, if x equals -3, we're assigning x the integer of -3 on a number line. What is the absolute value of x? So if you aren't familiar, those 2 little pipe signs around the actual value are the absolute value signs, and everything inside of the absolute value is what's actually being affected. You're turning that value into its positive form. So like I said before, we're calculating the value, the distance that -3 has from 0. So when you calculate that on a number line, all you're doing is counting 3 spaces back to the right, and that's positive 3 spaces. Distance can never, ever, ever be negative. So let me just write this down here. Distance is always positive. All right, so what exactly is x? What exactly is x in terms of the answer? So we can substitute some values for x to actually calculate that. Now we know that the distance between -3 and 0 is 3, therefore the absolute value of x is actually 3, but there are 2 possibilities that you can plug in for x. 2 values of x that would work are either -3 or 3, because they're both 3 spaces from 0. That's because they're direct opposites. Direct opposite values, meaning values that are equal distance from 0 and are constant distance, that are twice as much as the positive value of that set. They're going to have the same exact absolute value. So in this case, -3 or 3 are going to equal 3. And what is the actual answer to the problem? Well, the absolute value of x is always going to equal 3. Whether or not x is either -3 or 3, like I said before, you're always going to get that positive value of x because distance is always positive, and you're calculating that same distance from 0. All right, now let's move on to simplifying expressions. So we're going to start to build up once we've recapped that basic knowledge. And just to clarify, whenever you have a value of x, say for example, the absolute value of x equaling a negative value or any absolute value of any variable equaling a negative number, that automatically is false. It's a non-existent term because you can never have an absolute value equaling a negative. All right, now we're going to take a look at simplifying expressions. So these steps of simplification. So in terms of steps, we're going to start off with our very first step. You're always going to simplify the values within the absolute value sign first and make sure not to distribute. So this is when you're taking a look at an expression. So just to recap, an expression is just like an equation, except it's not equal to anything. So you're just simplifying it. That's all you can do with an expression. So when you're simplifying those values within the expression, you're going to simplify whatever's inside the absolute value sign first. And if you're multiplying anything with that absolute value sign, make sure not to distribute it. It works just like parentheses, but simplify within first. And if there are values being multiplied, like I said, distribute them to the simplified absolute value. So whenever you have an integer that's directly outside of your absolute value sign without any signs in between, you're multiplying. So like I said, simplify first, then multiply. Makes everything so much easier. And lastly, simplify the known term once you've multiplied the distributive factor into the absolute value sign, the simplified absolute value. Once you multiply that, the value within the absolute value sign, you're just going to make it the positive term. So you're going to simplify within the absolute value. So let me show you exactly what that looks like. So say, for example, let's take this expression, 2 times the absolute value of 3 minus 6 times 2. We're going to look at PEMDAS. So in this case, PEMDAS, that's the order of operations, parentheses, exponents, multiply, divide, add, and subtract. You can revisit Ronan's pre-algebra video to recap on that. But we're going to utilize PEMDAS, and parentheses and absolute value signs are both for P. So in this case, we're going to do what's in the absolute value sign first. So we're going to start simplifying. We do PEMDAS. We know you're going to multiply the -6 and 2 first because multiplication always comes first. So -6 times 2 is -12. So now you're left with 2 times the absolute value of 3 minus 12. Now we advance onwards, and we're going to simplify 3 minus 12. First, simplifying everything within the absolute value sign to get 2 times the absolute value of -9. And lastly, we're going to multiply them together now that our absolute value is simplified. So we get the absolute value of -18, which equals 18, positive 18, because the absolute value sign changes the symbol of 18. So just to recap, we always simplified every single value using PEMDAS within the absolute value sign first. Once that was simplified to -9, we multiplied it using the second step and to get -18. And lastly, with our third step, we simplified within the absolute value sign to make it positive 18, -18 to positive 18. That's just getting rid of our absolute value signs. That's all it means to simplify. All right, now let's move on to simplifying equations. Now that we've broken our expressions, we're going to look at equations. So, two-solution equations. That's exactly what equations are all about. Having two possible solutions for your given variable, x in this case. So, in an absolute value equation, there are always two valid solutions for any variable that you're using. And you must identify the distance the absolute value is from 0, the value within the absolute value bars, that's what I'm referring to, that variable, how far it is from 0, and you go in both directions. So you're going in a positive direction is over to your right, and a negative direction is over to your left. This is my left, this is my right. Essentially, you're going to be going in the opposite direction, equal distance in opposite directions to find the two valid values. And then you would indicate both solutions as your answers. So let me show you an example. So the absolute value of x equals 7. That's obviously an equation. We have an equal sign. We have two terms on each side. We're setting them equal to each other. With the absolute value of x equaling 7, let's start to graph it. Let's put it in graphical terms first. So let's take 7 here, right? We're going to take the term 0 right here. We're going to calculate the absolute value is the distance from 0. Like I said, absolute value is always distance from 0. So we're going to take our starting point at 0. Then we're going to start to move over 7 spots to the left. Let me just etch that out for you. So we're moving 7 spots towards the left in this way, this direction. And here we land at -7. So that's one of our valid solutions. And then now we're going to go over to the right 7 spaces. And here we land on positive 7 because they're both 7 from our focal point at 0. So these are our two answers, negative 7 and 7. And when you're writing that graphically, you would algebraically, you're merely writing x equals positive or minus 7. So whenever you're given your variable x without any adding or subtracting within or multiplying to, it's just x or a variable, and you're given another integer, you know that it's going to be either the positive or minus value of that given integer. The reason being is if we take either positive or negative 7 and we plug it back in for x, it's always going to be true. That's the only reason why there's two solutions and not just your positive solution. All right, now let's move on to absolute value inequalities. So we're going to take a look at these graphically and algebraically, taking them in pure English and turning them into both as our answer formats. So the problem goes as follows. The absolute value of x is greater than or equal to the value of 6. So how exactly are we going to solve that? So we're going to find what values of x actually equal 6. So like I said before in our previous slide, we're just going to build up off of that. We know that since it's the absolute value of x, we know that the values that will equal 6 are either negative 6 or positive 6. And make x, our second step is to make x less than or equal to the lesser value of those two and greater than or equal to the greater value. So let's write those down. So we have our values of plus or minus 6. And this just stands for positive 6 or negative 6. So with those two values, all we're going to do is we're going to make x less than or equal to the lesser value because it's saying it's saying greater than or equal to or less than or equal to. We're going to make our x less than or equal to a negative 6 because it's our lesser value. So x is less than or equal to negative 6. Because we're going in the negative direction, we're going to flip that sign. Like I said, always when you're going in, when you're utilizing negatives, you're always flipping the sign. And then for our positive terms, right here, we're going to make it x is greater than or equal to 6, the value of 6 in this case, because it's saying here you're going to make it less than or equal to the lesser value in this problem, then greater than or equal to the greater value. Greater than or equal to the greater value in this case, which is 6. That's always the case. However, if it's greater than sign, if its absolute value of x is greater than 6, then you would merely change that less than or equal to sign to a greater than less than or equal to sign to like a less than sign for negative 6, and then a greater than sign for x is greater than or equal to 6. So let me clear this up real quick, just to show you guys a quick demonstration of what I was saying. All right. And therefore, proper formatting for this, we would make a compound inequality here. We would say that x is less than or equal to negative 6, or x is greater than or equal to 6. Now, if you think about this algebraically, when you're coming to check the problem itself, if we take any value of negative 6 going onwards, and you're merely just taking those negative values and changing them to positives, they're all going to be positive values of more than 6. So it's everything less than negative 6, so it's going to be a greater actual integer value without the negative sign, and everything greater than positive 6 is greater than or equal to positive 6 is obviously going to work as well. And now if we're taking a look at our graph, how exactly do we graph this? Now, if you recall from our compound inequalities video and regular inequalities, the previous video, the predecessing video to absolute value video, to our absolute value video, you know that this is an or statement. So what we're going to be graphing is two separate inequalities going in opposite direction that don't interlap. They're separate inequalities. So if you look here, we have, switch to my pen, we have x is less than or equal to negative 6. So we're going to put a point, solid point at negative 6 because it's less than or equal to, and then we're merely going to etch our way onwards to the left. Let me just put this a little bit higher and thicken this. So we're going to be going in that direction. And then we're going to take positive 6 here because it's greater than or equal to positive 6. And we're going in this direction, the rightwards. So we're going in rightwards. And that is how we represent it graphically. Now on to our last slide, which was what we're going to build up in this entire lesson. We're building up to this type of problem here. We're going to look at expressions within equations. So we're going to make it a whole entire equation, but we're going to be adding other values outside of the absolute value and putting an expression within the absolute value sign, not just a smooth variable. So let's take a look at this problem. We're going to first start off with our first step. There's 3 steps when solving equations. The first step is called isolation. So you're going to try and isolate your absolute variable, your absolute value expression. So we take a look at this expression here, this problem. We're going to solve for x. In this case, we're going to solve for x, and we're looking at 3 times the absolute value of 2x minus 3 plus 5 equals 14. So how do we solve that? How are we going to isolate? Well, first of all, we're going to go in reverse of our PEMDAS, our order of operations. We're going to first look at our addition sign. That's something we're going to, addition or subtraction is what we're looking for first. So since we have plus 5 here, our first addition, and our only addition or subtraction here, we're going to subtract 5 from both sides to get 3 times 2x, 3 times the absolute value of 2x minus 3 equals 9, because we subtracted 5 from 14 and both sides. And then what we're going to do is we're going to divide by 3 to isolate that absolute variable sign. So we get 2x, absolute value of 2x minus 3 equals 3, because 9 divided by 3 equals 3. Then for our second step, we're going to split this absolute value equation. Now that we've isolated the absolute value expression on the left side, it's equal to one value on the right side, or integer value, we're merely going to split this up into 2 equations with different answers. Okay, so what we're going to do here, and this is probably the most important step here that many people forget here, and many people get confused, is what we're doing is we're splitting up the equation, we're taking out those absolute variable signs, and we're setting the expression, or the expressions, equal to 2 different answers. Now, all we're doing is we're taking the original equation, absolute value of 2x minus 3 equals 3, we're putting it in the positive form, meaning it's going to equal a positive 3, the positive form of the answer, so 2x minus 3 equals 3. But because it's absolute value, and like we said, we always take opposite values both work for the equation. We're also going to equal it to the negative form of the answer. So that's going to be 2x minus 3 equals negative 3, the opposite form of our original equation here. All you're doing is reversing that, because as you know, you can always plug in a positive or a negative value that are both the same distance from 0, and plug it into an absolute value sign to get the same answer. So that's always the case here. Your answer is always going to be 2. One is going to be the opposite of the other. Then you're going to do our next step, our third step, which is called solving. Now that we have 2 cases, one is our positive case, our original case for the equation, 2x minus 3 equals 3, and then we're going to take the negative solution, because you always have a negative solution. So it's a negative solution of the answer. So your answer equaling 3, you're going to have negative 3. Now we're just going to solve that. And as you can see on the left-hand side, we're going to simplify this equation as we would normally. So 2x minus 3 equals 3. You would add 3 to both sides to get 2x equals 6. We'll just write this here, 2x equals 6. And then you would simplify, divide both sides by 2 to get x equals 3. And then on the right-hand side, we have 2x minus 3 equals negative 3. What you would do here is you'd add 3 to both sides. We get that 2x equals 0. And if you further simplify that, you get that x equals 0 itself. So the key to this was the splitting step itself, not just the isolation or the solving part. The splitting step is the most crucial part of this whole process. You're taking your answer and you're putting the positive and negative form of it and setting that expression equal to both. And then you get 2 separate answers. So x can equal 3, or it can equal 0. We're just separating with that 0. If we plug this back into our equation, this would indeed work. Both of these solutions would work. All right, sweet. That's the end of today's video. I hope you guys enjoyed. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below and turn on post notifications so you don't miss out on any of our channel's latest videos. Check out our website at www.ecoreacademy.org to see our full unlocked access to what we as an online e-learning platform actually offer to you guys. We have full unlocked note sheets, quizzes, and worksheets that go along each and every single one of our videos, organized into their own separate course studies with many other features to come and help you guys learn a full entire course at the platform. So please check that out and make an account for free there. Also, email us at eCoreAcademy@gmail.com if you have any questions, and check out our socials in the description box below at Pinterest, Facebook, Twitter, Instagram, and TikTok. Check out all of our other teachers' channels here, teachers' courses here in mathematics, science, and other courses as well, like our Meet the Champs section and eCore Beyond the Books. We really do appreciate all of your support, and I hope you guys are really attentive to all the new content that we have for you guys. We're trying to stay up to date, trying to give you the best possible content, so we really do appreciate feedback as well. So thank you guys for all of your support and watching and sticking through this entire video. Stay in tune for our next video, Absolute Value Inequalities. Until then, I'll see you guys later. Peace.